Hello my dear students, welcome back to our channel. Here we are going to continue with the exercise 12.3, problem number 6. Here in this question, we have given a circular table cover having the radius is equal to 32 centimeter. 32 centimeter. Okay, and here a equilateral triangle ABC is formed in the interior of the table cover. Okay, and we have to find out the area of the remaining region. That means in the remaining portion there is some designs. Okay, we have to find out its area, that is area of the design. Okay, that means from the figure it is very clear, you will get the area of this design by subtracting area of this equilateral triangle from the circular table cover. Okay, so for that we have given only the radius of the circular table cover. Okay, so we have a circle with the center O and an equilateral triangle is there inside the table cover. Okay, so how it can be, that equation can be formed? Okay, that is very clear. You have to subtract, I already told, this equilateral triangle area. What is the equilateral triangle area of the equilateral triangle? That is root 3 by 4, root 3 by 4 a square. Here a is the side of the equilateral triangle. Being it is equilateral, we can write AB is equal to BC is equal to AC. That means all the three sides are equal because it is equilateral triangle and its area we know, that is root 3 by 4 a square. Okay, so in order to get the area of the shaded region, okay, let it be A. Okay, that means you have to subtract this from area of the circle. That means the whole circle, that is pi r square. That is, so this is the equation to get the area of the design, pi r square minus root 3 by 4 a square. For that we have given only the radius, that means you can substitute radius as 32 here. Okay, minus root 3 by 4, both are constants, and a square. But the side of the equilateral triangle, that is A denotes, that is not given. So our first task is to find out the A side of the equilateral triangle. Okay, see children, here in this equation, here we have two unknowns. Area is what we need to find out. Here for that, here the side is not given. Okay, and we know that if in an equation two unknowns, okay, we cannot get the value of the single variable. Okay, so the first aim is to find out the side of the equilateral triangle. Okay, and we know that for an equilateral triangle, okay, that is the altitude is the median. Okay, we can do this, we can solve this problem in different methods. Okay, I am explaining here the very simplest method to calculate the area of the design, or in order to find out the side of the equilateral triangle. This is the very simplest method that we are going to find out. Okay, so for that I already told, for an equilateral triangle, the altitude and the median both are the same. Altitude of an equilateral triangle or any type of triangle is the line segment from a vertex to its, the perpendicular line segment from a vertex to its opposite side. Okay, that means I am going to draw that one. Okay, for that children, we know that for an equilateral triangle, okay, that means the median and the altitude both are the same. Okay, and what is median or what is an altitude? Altitude is nothing but the perpendicular line segment from a vertex to its opposite side. Okay, and median, what is median? It is a line segment, okay, from a vertex to the midpoint of the opposite side of that vertex. Okay, but for the equilateral triangle, both these are the same. Okay, so 90-degree perpendicular and the midpoint, because of this is median. Okay, so let it be AD. Okay. AD is the median as well as the altitude of this equilateral triangle ABC. Okay, and here we are going to apply very important result. What is that? That is, the centroid divides the median in the ratio 2:1. Okay, so what is centroid? Centroid is the common point or the meeting point of all the three medians of an equilateral of a triangle. For an equilateral triangle, okay, so this, and it is, since it is in the inside the circular table the region, okay, that centroid will be the center of the circle. Okay, that means this is AO, that is the one part. That means that point, that is center of the circle, is the centroid for this equilateral triangle. And since the centroid divides the median, and what is median? AD, in the ratio 2:1. 2 part and OD is 1. Okay, and what is AO? AO is radius, that is given. Yes, children. Then how can we are going to form very important step? This, can we write this radius, that is AO, is, what is that? That is 2 out of 3. How this 3 comes? 2 plus 1, sum of the ratio. Okay, out of this 3 equal parts, 2 is for AO, that is radius. Okay, that is AO, that is radius is given as that is AO or OA, that is the radius, and that is given as 32 centimeter. And since the centroid divides the median in the ratio 2:1, this AO will be, what is that? 2/3 of median. What is median? AD. Okay, AD, this is equal to 32 centimeter. I hope this step is clear. How this 2/3 comes? Because of this ratio. Okay, and AO is, out of these 3 equal parts, 2 part is for AO. That AO is given as 32. So we have written this AD in terms of AO. Okay, that is 2/3 of AD is radius. That is AO is the radius, that is given as 32. Hope this step is clear to everyone. Yes? Okay, now we are going to find out the median or the altitude or AD. With respect to this figure is AD. Okay, that means which implies AD is equal to, we have to take this to that side, the reciprocal of 2/3, that is 3/2, or 3 can be taken and 2 will come the denominator. 32 into 3 divided by 3, isn't it? Okay, and you will be getting, that is 32 into 3 divided by 2, this 2. Okay, and 2 in 32, 16, and 16 3s are 48 centimeter. This is AD or the height or the median. Okay, why we have found AD? Because we are going to find out that side of the equilateral triangle, and that is nothing but AB with respect to this triangle. Okay, this triangle, in the sense, next I am going to see, we haven't reached our destination, children. Okay, we have to find out AB. Okay, so in order to find out AB, AD is the first part that we have already seen from this very important result. The centroid divides the median in the ratio 2:1, and we have found that this AD is 48 centimeter. Okay, now children, see, I already told this median is the altitude for the equilateral triangle. So in order to get AB, now you consider equilateral right triangle ADB. Okay, right triangle ADB, because you can easily calculate that AB by applying Pythagoras theorem. you will get AB. Okay, so that is the next step I am going to write over here. Okay, we have seen that AD is equal to 48. I think that step is very clear to you people. Okay, now in order to get, so I am writing over here, that is we have seen that AD is equal to 48 centimeter. Okay, now consider right triangle ADB. I hope how this comes as right triangle is clear. AD is the altitude. So 90 degree, if one of the angle is 90 degree, that means that is a right angular triangle, so that you can easily apply Pythagoras theorem, right? Okay, so AB is the hypotenuse. Square of the hypotenuse is equal to sum of the squares of other two sides. Okay, so other two sides means AD and BD are the other two sides of right triangle ADB. Okay, so we have seen that we are going to find out AB, right? So AD as 48 square plus, this is another important substitution. Okay, so BD, I already told AD is the median, that means D is the midpoint of BC, right? Okay, and we already have written here that for an equilateral all sides are equal, so AB equal to BC equal to AC. Since D is the midpoint, okay, here you can write A before AB, BC equal to, or BD. Can we write this BD equal to half of BC? Half of BC, right? Because D is the midpoint. So this portion will be half of the total length of BC. And we know that since AB equal to BC, I am going to replace this BC by AB. Okay, that means BD equal to half of AB, because I already told, okay, this equation should be of with one variable. Okay, here you can see here over here AD we already substituted, and we have AB we don't know, and BD also. So that is why I have converted or substituted BD in terms of AB very easily, because this is an equilateral triangle, all sides are equal and D is the midpoint. So BD will be half of AB, that is half of BC, and BC is nothing but AB. Hope this step is also clear to you children. Okay, so here I am going to write half of AB whole square, this square remains. Okay, so the next calculation, 48 square plus AB square by 4, that is this is AB by 2, right? Okay, AB by 2, A by B whole square is A square by B square, numerator square divided by square of the denominator. So that is how this becomes 4, AB square divided by 4. Okay, so I am taking this AB square by 4 into LHS. So this plus sign becomes minus. So which implies AB square minus AB square by 4, this is equal to 48 square. So since they are connected by minus, plus or minus you have to cross multiply. If it is into, you can reduce. Okay, I think that is clear to you. So 4A square minus B square is 3AB square. Okay, 4AB square minus AB square. Okay, divided by 1 into 4, that is 4. This is equal to 48 square. This step is clear children. Okay, I have taken this, okay, cross multiplication, 1 into AB square, that is 4AB square minus AB square is 3AB square, and divided by 4. Okay, so I am going to rub this the steps. Okay, yes. So in the next step I am keeping only AB square in LHS by taking 4 to numerator and 3 in the denominator. I hope that also clear. Calculation is very important children. That is up to you. You can do your own calculation, doesn't matter. Okay, into 4, okay, divided by 3. Okay, but we need AB. This is AB square. So in order to get AB, you have to take the square root. Okay, on the RHS. So 48 square into 4 divided by 3. The whole expression will come under the square root. Okay, so I am going to rub this step also, children. Okay, see, listen carefully in the in this equation. Okay, so children listen. So root of AB, what is root of AB? Root A into root B, right? That is the general rule that we have learned in the smaller classes. Okay, so here in the numerator and denominator I am going to split, that is root 48 square into root 4. Root 48, this step is not compulsory to write, but in order to make you more clear I am writing this step also, into root 4 divided by root 3. Hope this step is clear. Okay, since they are connected by into, we can take a square root separately. Okay, so square root and square get cancelled. So square root of 48 square is 48, simply 48, and square root of 4 is 2 divided by root 3, that is 48 into 2 is 96 divided by root 3. And we know that we have to, if the irrational number comes in the denominator, we have to rationalize. Okay, so multiplying and dividing this with the root 3 into root divided by root 3. Okay, so that comes in the next step. 96 divided by root 3 into, we are going to rationalize this. So root 3 into root 3 in the denominator, it will come simply 3, and in the numerator 96 root 3 divided by 3. Isn't it? So 3 and 96 can be reduced because they are connected by into, root 3 and 96 into. So you can reduce. Okay, so 3 in 3, 3 times and 6 and root 3 remains there. So root 32 root 3 is AB, that is the side of the equilateral triangle. Hope this step is also clear to you. Okay, first we have seen that what is AD, because we have an intention that in order to get AB, the side of the equilateral triangle, okay, we have to apply the Pythagoras theorem, that is the simplest method. Okay, and also the altitude and the median are the same for an equilateral triangle. So you can apply Pythagoras theorem. So that means we can easily calculate, okay, or if you know all these steps correctly. Okay, I hope that I explained very well for you. Okay, so AB will be 32 root 3 centimeter. So in the next step, here A denotes the side. So AB you can substitute as 32 root 3. Okay, so in the final step, okay, that is in order to get the area of the design, okay, 22 by 7 4 pi, radius is given as 32 into 32 into root 3 minus root 3 by 4 into now 32 root 3 into 32 root 3. Okay, now the final calculation. Hope that now this is clear to you, children. So I am writing here. So 22 by 7, 32 into 32 is 1024. Okay, square. Okay, 1024 minus root 3 by 4 into, okay, again 32 into 32, root 3 into root 3 is 3. Okay, so 32 into 32 into 3. I hope how this is clear. Okay, root 3 into root 3 can be written as 3. So we know that 32 into 32 is 1024, right? This 32 into 32, because they both factors are combined with the into. So 32 into 32, root 3 into root 3, 3. Okay, now the final calculation. Okay, that means the 22 into 1024. That multiplication I am doing here. 1024 into 22, 8402, 8402. That is 82522. Okay, that is 22528 divided by 7 minus. Here you can reduce, okay, because we know the divisibility test of 4, that is either last two digits 0 or last two digit make the number multiple of 4, you can reduce that number with 4. Whatever the big number, it will be divisible by 4. So 4 in, so 24 6 LA. So 4 in 10 2 times. Okay, remainder 2, 22 5 times. Okay, 20, so again remainder 2, that is 24 6. So 256 into 3. Okay, that is 2 and into root 3. So 6 18, 1 carries, 15 16, 1 carry, 768 root 3. Okay, so this is the final answer. This is the area of this many centimeter square. This is the area of the design. Okay, after subtracting, okay, area of the equilateral triangle from the area of the circle, because the circular shape that is given in the question, that is table cover is circular shape. Okay, so here the very important step is to find out the side of the equilateral triangle, radius being given as 32, and since the center divides the median in the ratio 2:1, we can easily calculate that is AB. We have seen that the side, we have seen that that is 32 root 3. Okay, then the final calculation. I hope this problem is very clear to you, children. Okay, so let us move to the next problem. Now this is the 7th problem. Here we have given a square ABCD with a side equal to 14 centimeter, right? And at each vertex of the square, a circle, that means you can see 4 circles in the figure, such a way that this one circle touches 2 circles of the remaining 3 circles externally. Okay, with respect to this circle, okay, you can see 3 circles, and this particular circle that with the center A is touches this circle with the center B and D externally, that means without overlapping, no portion comes in the interior portion of a circle with the center A, with respectively for all the 3 circles. Okay, so the remaining 3 circles, the circle A touches these 2 circles externally. Okay, that means here, and what is asked? Here we have to find out the area of the shaded region. It is quite simple question. Everybody knows how this area of the shaded region can be calculated. Yes, of course, children. If you subtract the area of these 4 shades from the area of the square ABCD. Okay, just like the previous problem. Okay, there we have subtracted area of the equilateral triangle from the area of the circle. Okay, in order to get the remaining portion, that is the design. Here in this question, okay, here the shape in the sense, since it is circle, square, each angle is 90 degree. That means 4 quadrants should be subtracted from the area of the square. How quadrants comes clear, children? That means each angle is 90. So 4 quadrant, that is area of 1 quadrant, that means 1 by 4 of pi r square, or pi r square by 4. Okay, likewise we have 4. So 4 into pi r square by 4, that is 4 get cancelled, or 4 quadrants will make 1 circle. Okay, and what will be the radius? Okay, that is why the first explanation is very important or valid here, because here this circle touches 2 of them externally of the remaining 3 circles. That means here the side, that is AD or AB, or all the 4 sides are equal, being it is square. Okay, so R is nothing but half the side, or here the diameter or the side will be, okay, if you subdivided this side with the 2, okay, you will get it, or the half of AB will be the diameter, radius of the circle or the quadrant. Okay, so that is very simple. That is the meaning of it. Externally it touches, okay, the two circles of the remaining. Okay, so that means here the radius will be half of each side, okay, with respect to all the four circles. Okay, that is why I already told it is very simple problem. Okay, so in order to get the area of the shaded region, so many times I told we are representing that with any area with letter A, but we have to write area of the shaded region. A is equal to, what is that? That means if you subtract this four quadrants from area of the square is A square, or side into side, minus, here a small a denotes side into side, okay, minus 4 into pi r square by 4 quadrants, okay. So area of one quadrant is pi r square by 4, or you can multiply, you can apply area of sector, being this is the area enclosed by 2 radii and its corresponding arc. Okay, so theta by 360 into pi r square, theta 90 by 360 will be 1 by 4. Both are the same, right? Okay, so 4 get cancelled. So a square minus pi r square, and a is given as 14 centimeter side of the square. So 14 into 14 minus 22 by 7, and here radius is equal to AB by 2, and AB is 14 by 2, that is 7 centimeter. Okay, so 7 into 7, 7 get cancelled, and 14 into 14, square of 14 is 196. Okay, 196 minus 7 and 1 7 get cancelled with the denominator. So 7 2s are 14, 1 carry, 154. Subtracting, you will be getting 2 and 5 to 9, 42 centimeter square. This is the area of the shaded region. Okay.